Hello, everyone. My name is Robert Zhu. Let me get these slides up first. Okay. I'm a software engineer at the Facebook Boston office where I work on GraphQL. I'm so excited to be here today at GraphQL Summit. What an audience. What a venue. I've met so many awesome people, and I hope to meet many more. But I want to tell a quick story first. I love visiting San Francisco. It's always a treat for me because I get to hear the most interesting conversations happen. I was at my hotel last night, and I heard these two people talking. And it occurred to me that they worked at a startup. And they were talking about how they were going to earn the business of a very important client. And the first person says, their existing service provider gives them 4 nines of availability. How are we going to compete with that? And his partner says, don't worry, we're going to give them 5 eights. I love San Francisco. All right, GraphQL subscriptions, the full stack. Let's go. Here's a quick run through of the agenda. I have made the terrible mistake of preparing an interactive demo for all of you. So we're going to watch that crash and burn. And then from that, we're going to understand subscriptions, what they are, why you want to use them, how you use them. And then we're going to transition over to talking about building your own GraphQL subscription server. What are some of the considerations that you need to make when you're building one of these out? What are the building blocks? What are the challenges that we faced at Facebook when we built this? We're going to compare and contrast subscriptions with another reactive GraphQL mechanism that people may have heard of called live queries. And then at the end, I'll have a resources slide with links to everything that I've covered. So you don't have to worry about taking pictures of any of the slides as I go through them. All right. So those of you who would like to follow along, please open your browser to graphql.tk. Enter your credit card, your PIN, and your mother's maiden name. It's all part of the demo, trust me. And I'll give you some time to open that up if you want to follow along with your laptops. Don't be shy. We should be seeing the demo now. Oh,
It may
right.
default to 720 each time.
OK. Can everybody see that OK? In the back? All right, I've got a thumbs up. And those of you who wanted to follow along, I assume that's enough time to open up in your browser. So this is graphical. Many of you have seen this before. And I'm just going to start exploring the schema using the Documentation Explorer. As usual, we'll start with queries. And when I click through the queries, I see there's this houses root field. If I click through here, I see it returns a collection of houses. Each house has a name, an integer count of the number of bannermen, and words. Any guesses what this schema represents?
Game of Thrones.
Yes. I love Game of Thrones, so I couldn't help but build this demo around my favorite TV show. So let's just execute some queries. For all the houses, I can fetch the name and the bannerman count. All right. So cool. Somebody's already begun using it. Thank you. We've got the houses, and for each house, I've selected the name field and the bannerman field. And I can change my mind about this, and I can pick out words. So there's an interesting story behind this. This is a recent addition to this demo, because the last time I did this, people thought it would be a good idea to script a loop and just endlessly hammer this thing. So this demo will be dependent on the goodwill of the audience. OK, so we've got this query executing successfully. Great. And we're seeing that we can select the fields that we want from the client. And we know that this is one of the existing things that makes GraphQL awesome. These numbers have also been changing, so let's take a quick look at how we did that. That works because for mutations, we have this pledge mutation, and we can see that it takes as a parameter one of these values, these houses. Let's go in here and execute one of those. Let's pledge to Tyrell. And then we'll also fetch the name and the bannerman. Cool. So we just saw the mutation. We saw that the mutation is a combination of a state change and a subsequent fetch. That's very handy, because I want to know whether or not I've pledged myself to a loser. Let's switch back to the slides for a moment. OK, what just happened? Well, we saw GraphQL. And when we hit the play button, we saw a response come back on the right side. Let's go into that in a little more detail. We know that when we hit play in the GraphQL, we send an HTTP request to the GraphQL server. And this demo happens to be running in Express. And when Express gets this request, it pulls out the GraphQL document in the HTTP request. And then it's subjected to execution with the GraphQL server. And this goes through 3 steps. The first is that we're going to parse the document. And when we parse it, we're going to enforce some rules, like curly braces need to be matched. And those rules are defined in the GraphQL language specification. Next, we can't just specify any selection in our document. It has to be valid with respect to the schema. So if I had included a field like foo, it wouldn't make any sense, because none of the types have that field. And if it passes validation, then we get down to execution. And that's when we actually execute the resolvers associated with each of those fields. And as those resolvers come back, we take the responses, and we assemble it into a JSON string. And then we send it back to the client. Once it gets to the client, we've got a response. We've got JSON. What do we do with it now? Well, the answer is whatever you want. We often talk about it in terms of sticking that JSON response into a store and then using that store to trigger some sort of update in our dynamic view layer. And that's a very common and useful use case. But back here, you can really do a lot of other things. You can write this to a file. You can kick off another request. You can start an automated process. So I have this slide here because I want to emphasize that GraphQL is useful outside of the context of just attaching it to some sort of web view layer. Let's observe that queries and mutations both follow this request-response style interaction. They're both client-driven, which allows us to fetch exactly the data that the client needs. But what about real-time data? How exactly would we build an app that displays real-time updates? Kind of tricky with request response, right? As we saw from Dan's talk earlier, we could just poll. And that might get us quite far, actually. But we may come upon a situation where the scale of our app and the nature of the request means that we want some sort of push-based solution. So let's go back to the demo. In the schema, we have a third operation down here, the subscription. And the subscription operation type allows us to subscribe to real-time data in GraphQL. So if I click through here in the docs, we can see that there's a power change subscription. And we can see that it returns a collection of houses. So if I come over here into the left, and I just say subscription, I want to get the name and the bannerman count. Execute this thing. So I can see these changes coming in real time. Somebody is making sure that Gryffindor is the most powerful house in Westeros. But this is happening from somebody in the audience, probably, right? This is really cool. We have just did an interactive demo. I think it's pretty cool. So we'll check back on this at the end. I want to see who wins. I want to see if anybody can upset this Gryffindor here. But yeah, so hopefully this makes sense, right? Before, what we're used to seeing in graphical most of the time is we execute a request and we get a single response. But what we're seeing here is something slightly different. We're seeing a request followed by a stream of responses. And this stream of responses tells us when the state that we care about changed. OK. Let's switch back to the slides. And I think you should all be able to, anybody trying to execute one of these in the audience? Yeah? OK. All right, what did we just see? Here's what the specification says about GraphQL subscriptions. If the operation is a subscription, the result is an event stream called the response stream, where each event in the event stream is the result of executing the operation for each new event on an underlying source stream. Executing a subscription creates a persistent function on the server that maps an underlying source stream to a returned response stream. I wrote this, and I apologize. But there's some interesting concepts here. And what I want to do in the next couple of slides is unpack what this means with a couple of concrete examples, so that hopefully it will make complete sense for you. Let's begin with this notion of a source stream. What is it? And how exactly do we turn it into the response stream? I'm going to begin by talking about a concrete event system. And the example app that we're building here is a messaging system. The idea is that if you have an account and you're logged in, you can message any other logged in user. And suppose that we decided to build this using a microservices architecture. And we have 3 microservices. We have the account management microservice that handles account creation and verification. We have the session service that handles user login and issues an auth token. And then we have the messaging service that actually processes sending messages from one user to another. In such a system, we might bridge all of these microservices together using an event bus. Here's an example. When I create an account, the account microservice publishes to this event system that an account was just created, such that anybody who is curious about this event can subscribe to it and react. Then when that user logs in, the session service might publish a login event. And once the user's logged in, now they're free to send messages to other users, perhaps more than one. So this is how publishes are going to work in our event system. Now let's say we have an interesting requirement. When a user logs into the session service, we notice that in some cases, accounts are compromised shortly after we can detect logins from vastly different locations. So we're going to create a new feature in our app. We'll call it the alarm service. And this thing detects suspicious login activity and flags the account before it can do any damage. In this case, the alarm service is now acting as a subscriber. When somebody logs in, the alarm service says, hey, I'm interested in that login attempt. And so it subscribes, it grabs it off the message bus, and it looks at it. And let's say that this login event was, I logged in from San Francisco. But 30 seconds later, I get another login attempt from Singapore. And the alarm service may have logic that says, hey, hold on a second, what's going on? Let me flag this account. So that's an example of an event system. And hopefully, that makes sense to everybody. I don't think this is a very complicated example. Now let's just take that entire event system and coalesce it into a single box, and we put it up at the very top of the diagram. Now we're ready to explain what we saw when we executed that subscription. Instead of an HTTP request, we know that this is a request stream semantic. So in this case, we're sending it over a WebSocket. We send it to the subscription server, and the subscription server, as before, takes the GraphQL document out of the request. But notice that the document is missing a chunk. That's because the document is only executable in association with an event. So the other thing that the GraphQL subscription server is going to do is inspect this document and its query variables, and from that derive some set of events or from some way to construct the source stream. So that when the event comes, it says, hey, I care about that event, give it to me. And then it has an executable form of the document, which it can submit for parsing, validation, and execution. And if all of that succeeds, then we have a JSON response, and it goes back to the client. And the part on the right should look very familiar to queries and mutations, to request response. That's not an accident. That part of the system remains entirely stateless. And as Dan mentioned, the evolution of subscriptions is that it was incremental. It was additive on top of the existing system. Now let's take it back to the spec text. The event stream at the top was just an example of how you can implement a source stream. And the response stream is down below, where we're actually using this to send the GraphQL responses down to the client. So hopefully that demystifies the spec language that we've used to describe this. I think there's some very important things in there, and hopefully this makes it make more sense. So what's not clear from the diagram there is the life cycle of subscription. And let's just go over that real quick. We know already that the request includes a GraphQL document and the variables. But once it subscribes on the server, we have to derive the set of domain-specific events from the document and the variables. In other words, we have to construct that source stream. And then we have to subscribe to those events on the source stream, such that whenever an event from the source stream occurs, we combine it with the document, and then we execute it. And if it all goes according to plan, then we have a response that we can send back to the client. So in terms of building blocks, this means that a system that supports GraphQL subscriptions needs a couple of additional components that weren't present when the system was stateless and only satisfied request-response style interactions. The first is that we need to support a persistent streaming transport. It's no longer sufficient to just issue a single request and get back a single response. Second, we have to have some general purpose storage because we now have state that we need to keep track of. One example of this state is the connection map. So who's connected to what gateway, and how do I send messages back to that subscribed client? And I also have to keep track of the subscriber info. When somebody subscribes, who are they? What document did they subscribe to? And what were the variables that were included? We need an event system, or some way to construct the source stream. And lastly, we need to be able to detect and publish these events. As we saw from that event system example, if nothing published, there's no way that our alarm service would have worked. So at the moment that the state changes in a way that we've identified it as a domain-specific event, we have to publish that fact. And that leads me to a warning. Scaling state is hard. By and large, we know how to scale stateless services. The answer is that we clone out a bunch more. But when you have state, for example, all of the state that we just described in the past couple slides, then you have an additional challenge, because if the node that contains that state goes down, how does the system react? And this is not just a technical problem. I'm sure many of you have heard of the CAP theorem. And when you're trying to scale state, you now need to understand what are the trade-offs that the product should make in the event of a network partition. The demo that we saw, it was all running in a single node process. So let's do a quick exercise and see what it looks like to take the single process demo, the single process subscription server, and imagine that we wanted to remove the rate limit that I had added. And we want to make it distributed so that everybody can vote for their favorite house however often they want. Well, we're going to need more capacity. In both the single process and distributed cases, we still need a streaming transport. And here are some examples of what you can use. WebSockets, SSE, HTTP long polling. And even had a great conversation about webhooks yesterday. That works too. For connection handling, every WebSocket connection terminated with that single node process. But that's not going to cut it if we want to deploy this thing at scale. We need a gateway layer whose job it is to terminate these connections and to handle these connections in a way that is decoupled from the rest of the architecture. For the source stream, if we're continuing to use the pub/sub style system as our source stream, in the single process, it's simple. It's just an event emitter in Node.js. But if we want to go distributed, we're going to have to add a component that is much better at dealing with the state that comes with a pub/sub system. And we can look to Redis, Kafka, Pusher, lots of solutions out there. And then for subscription session data, it sufficed in the single process case to store this either in memory or in a flat file. But I'm going to need a real database or a cache layer to store this information in the distributed case. All right, GraphQL subscriptions at Facebook. You got a preview of this from Dan's talk earlier today. But if you use Facebook, you're using GraphQL subscriptions. These are some very popular features that are powered by GraphQL subscriptions. Live likes, live comments, streaming reactions on live videos. So this should give you an idea of the stuff that we've built with this system. And the current state of it is that it's officially part of the GraphQL specification. And this was the result of a very close collaboration between Facebook and members of the Apollo team. And I couldn't be more proud of the outcome. It is part of the GraphQL.js reference implementation. There is support for it from front-end frameworks such as Relay and Apollo. And GraphQL is a really cool backend that also supports subscriptions out of the box. All right. Now let's talk about live queries. Subscriptions is not the only way to do reactive GraphQL. We've talked about this concept of a live query for a while now. And the idea is very simple. You take an existing query, and you add an @live directive to it, send it to the server, and instead of getting a single response, you're going to get a stream of responses that simulates what you would have received had you pulled that query infinitely fast. It's just that the server is making that operation much more efficient. So because we have these two ways of doing reactive GraphQL, we frequently get this question of, well, what are the differences? What should I use? And I think the long answer to that is going to be in Rodrigo's talk tomorrow, which I highly recommend you attend. It's going to have a lot of really interesting details for our journey in building live queries. And I stole this slide from Rodrigo's talk because I think it is so good at summarizing the difference. The difference between subscriptions and live queries is the difference between observing state and observing events. If we have a value that changes over time, and at t and t+1, t+2, et cetera, we sample the value, the difference between subscriptions is whether you're observing the state change itself, the value itself, or you're observing an event, for example, that the value is incremented by x. Okay, so for example, let's say the value at t was 5, and the value at t2 and t3 was 15. You could have made that transition either via a subscription that said, or an event that said, the value is incremented by 10, or you could have simply observed that the state made that change and then deduced that the value changed by 10. And as I like to say, there's no silver lunch. And there is also no slide either. Yeah, so this is so here are the trade-offs to summarize the differences between subscriptions and live queries. Let's begin with the requirements. They both require this concept of a streaming transport. But beyond that, when you consume these, you need some sort of reactive API or language. And an example of this is that as we add this to the specification, we discovered that a mechanism like an async iterator in JavaScript is really useful for modeling this kind of thing, or observables if you like those. For subscriptions, we need something that can constitute the source stream. And most often, that is going to be some kind of event bust. But for live queries, we need a reactive data layer. And the asterisk is that this is a very interesting problem, and it requires a lot of creative solutions. As for benefits, subscriptions, when a subscription event triggers, you know exactly why the data changed. Whereas you may have to reconstruct that information by diffing the states in the live query case. For subscriptions, you also have fine control over the publish. So the end-to-end flow of why did this thing trigger is more explicit. And on the live query side, you can theoretically convert any existing standing query into a live query. And you can also fall back from a live query to polling, which is very useful. And then once you have your reactive data layer, no other server-side changes are required to enable live queries. So that's it. Here are the resources with links to everything that I talked about. I think I'm a little over time. But the takeaways I wanted to leave you with are subscriptions. That demo that I showed you was built entirely with open source components using the Apollo client. So definitely go check that out. It's really great work. Check out the specification. And definitely check out services like GraphQL that let you get up and running with subscriptions very quickly. Okay. Thank you very much.